Hello, hello, hello. Welcome, welcome, welcome to another rendition of Math is Easy Step by Step. I would like to go over a series of videos concerning solving multiple step equations. What I like to do is go over a couple of very key concepts that you really need to know in order to perform and solve for the variables, right? Remember, variables are symbols that represent a real number. And our goal is one of the first steps that you want to take in solving multiple step equations is to get all of the variables, the same variables on one side, that's the left side, or the right side of the equal sign. How are we going to do that? We're going to do that using inverse operations. And that's all I'm going to be showing you here on this first page is inverse operations. That's moving a term from, let's say, the left side to the right side of the equal sign. I'm not solving problems right now. I just like to go over some very key concepts. So let's talk about an very important point, a very important point here. If you want to move a term, it's going to be the opposite of adding or subtracting, right? So if you want to move a variable term or any term to the other side of the equal sign, right? Plus 3x is a term, plus 7 is a term. If you want to move a term from one side of the equal sign to the other, you're going to use the inverse of adding or subtracting. So whatever it's showing you, right, you're going to perform the opposite of adding or subtracting. If there's a term on the left side of the equal sign that's a positive, then you're going to subtract both sides, the value of that term. If there's a term on the left side of the equal sign that's a negative, then you want to do the inverse or the opposite, and you want to add that term to both sides. So simply put, you want to move a term, you're going to be doing the opposite of adding or subtracting to move the term. You want to isolate a variable and solve for a variable. It'll be opposite of multiplying or dividing. We'll get into that in the next page, number 2. So let's take a look at here this example. 2x plus 3 equals 5. All I want to do is show you an example of an inverse operation of adding or subtracting. I'd like to move a term that's on the left side over to the right side of the equal sign. How do I do that? I do the opposite. So I have a plus 2x, I have a plus 3. So what's the opposite or the inverse of adding? It's going to be subtracting. So I'll subtract in this example, and again, I'm not solving for x, I'm just showing you how to move a term from one side of the equal sign to the other. I'm going to do the opposite of a plus 2x, I'm going to subtract 2x, or take the negative inverse value of 2x to both sides. Okay, and you can only add or subtract like terms. Positive 2x and a negative 2x cancels out to be 0. I'm going to be left with a positive 3 equals 5 plus a negative 2x term. Now these two terms are not like terms, so I cannot join them. It's just going to stay in this form. And so you could also write that as an example. You could also, in exponential order, you want to write on the right side of the equal sign, the x value would come before the constant term of positive 5. So you could write it this way: 3 equals a negative 2x plus 5. All right, let's get into some more important points here. I'd like to start with another important piece of information that you really should know when solving these multiple step problems. Hey, if you want to get a variable, remember that's x, y, and z all alone. That's what you have to do in order to solve for a variable. If you want to get it all alone, you're going to use the inverse or the opposite operation of multiplying and dividing. So that second step, that last step, will be you multiplying or dividing that coefficient with that's attached to that variable. And so let's go over an example here. I have 3z equals 9. So again, I'm wanting to show you how to free up that variable from that 3. 3 is attached to z through multiplication. What's the inverse or the opposite of multiplying? It's going to be dividing. So I'll divide both sides of the equal sign by 3. And I'm going to show you that here. 3 divided by 3 is that invisible 1z. Z is now all by itself. And what I do to the left side of the equal sign, I want to do to the right side. 9 divided by 3 is 3. Z equals 3. You could check your answer, substitute that. If z equals 3, you could substitute 3 for z. 3 times z is 9. 9 equals 9 is a true statement. Z has got to equal 3. So again, just showing you the inverse operations to free up that variable. If I'm going too fast, please stop, pause, rewind, do as you need to do in order to gain a better understanding. Number 2, this is a second example of inverse. Now, you want to solve the problem for a variable. You need to get that variable all by itself. So here I have 1z divided by 3 equals 3. Now, a lot of times you'll see a solid 1 over 3, 1/3, and that z will be here in the middle. You can raise that z up right along that 1, and it would be perfectly okay to do that. You have 1/3 z, or 1 times z divided by 3. It's exactly the same thing. It's just a different way of writing it. So you can clarify what you need to do. In this example, the inverse operation of division, every fraction is a division problem, and the opposite of divide is to multiply both sides by the value of 3. Let me show you that here. I'll show you a couple of steps and the solution. So here I'm showing you 3 times the invisible 1z. Now I use invisible ones. Can you write a solid z right there? You absolutely could. And so that 3 has an invisible 1 in the denominator's place. Hey, could you write a solid division bar and 1 in the denominator's place? You absolutely could. So I'm just showing you here instructional wise, 3 times 1 is 3z. 1 times 3 is 3. Now what I do to the left side, 3 times z, I have to do to the right side of the equal sign, 3 times 3. 3 over 3 reduces down to that invisible 1. Z is all by itself. And 3 times 3 on the right side of the equation is 9. Again, that 3 over 3 is a 1z. Z equals 9. You want to check your answer? Substitute 9 for that z. Of course, 9 divided by 3 is 3. Does 3 equal 3? Is that a true statement? Then yes, z has got to equal 9. Hey, thank you for joining me. Hopefully this made things a little easier for you. Math is easy. Take it step by step.